Section 4 is about transformations of functions. We're going to review different type of functions in this section. We're going to look at the different type of transformations that can happen with a function. But before we even start some examples, let's review different type of functions that we can see and how the transformations can impact the basic function for each category. So let's go ahead, and this part I did not put it in, I forgot to put it, or let's say not forgot, when I was creating the guided notes. I did not have in my head that this would be important for me to put in this category, but we have it now. So it's posted on Blackboard. You can print it out, or you can just write this part of the notes in a blank sheet of paper when you're turning in your note. Remember to include these next two pages in your notes before you submit your notes. All right, so let's now look at three parameters about each type of functions. First thing, we're going to look at the graph of each function. So I'm looking at this graph here, which is the graph of a linear function. So first thing is the graph of the function. The second thing would be the name of the function, which is the equation of the function, f of x equals a, where a is a real number. A is a real number. And next, we also want to know the name of the function. So it's it's a constant function. F of x equals a, function is constant. So there is no variable on the right side of the equation. That's why you see a horizontal line, a straight horizontal line that passes through the y-axis only. In this case, the graph that is shown is a equals 4. So in this case, a equals 4. It's f of x equals 4. But that can be any number. If it was -2, you would see, if f of x was -2, you would have a straight horizontal line passing through -2 and so on. The next, so that's the constant function. The next function is this graph here. We will discover the name, and it looks like a straight line. The equation of it would be the f of x equals x. That's the identity function, but it's also linear. So to be precise, it's going to be the identity function. Because f of x is itself. F of x is x. So that's why if you take x equals 2, you would get f of x is also 2, because f of x is x. So that's the identity, but that's also the same as a linear function, in case you would be looking at a more complicated linear function. So that's the identity. Or also linear function. Linear function, we saw it in the section 3 in a slope-intercept form. F of x would be mx plus b. So that's after transformation. You would, on the x value, you would get this result, but the linear function, is the actual f of x equals x. That's the basic function for the linear function, which is the identity. The next function will be this graph. That's the shape for a function like this, and that's the basic function in this category, which has the equation f of x absolute value of x. So obviously the name is absolute value function. We'll keep on going. You see the parabola here, a U shape. Remember, the absolute value function has a V shape. Well, obviously, when you transform, you would get a V that is being transformed, that can be closer to the y-axis, closer to the x-axis, move to the left. You can have a function that moves to the left, move to the right, move up, move down. All of these will be considered as transformation. After we can do all of that, but we need to understand that the basic function that will be subject to those transformations will keep the same base shape of the same shape of the basic or parent function. So that's why we are trying to identify all the parent functions. When we see the transformed function either on a graph or the equation, we know where the parent, what the parent, this function, which parent the function came from. Next is this parabola. Parabola has a U shape. It has a U shape, and the basic equation of the function is f of x equals x squared with the name quadratic. So quadratic functions have a equation f of x equals square. Whenever you see a square present, no matter what transformation happens to on the inside, on the outside, inside and outside, I'm talking about before taking the square or after the square for the x, we would know that this is the quadratic function that was subject to some transformation, either on the equation or the graph of the function moving up, down, closer to the y-axis, closer to the x-axis, will be the same parent function, which is quadratic. Next function, it looks like a S or whatever you want to call it, and that's a cubic function. F of x equals x cubed. Cubic function. We're looking at this. That's going to be the square root function. F of x equals radical square root of x. And then, like I said, the function is the square root function. And so on. This is this graph here is also one of the parent functions you need to identify when the graph is given to you, whether it's transformed, but you need to know what type of parent this function came from. So that's going to be f of x equals cube root of x, and that's a cubic function. That's a cube root function. Next function is the exponential function, f of x equals b to the x power. When transformed, it's going to keep the same shape, exponential function. That is the logarithmic function. When transformed, you're going to still see the function, the shape that you see here with some transformation, but the basic shape will remain for the transformation. Logarithmic function. And then last example that I want to show you is this curve that is from the parent function f of x equals the parent inverse function, which equation is f of x equals 1 over x. All these parent functions that we are looking at now will be subject to transformations. Now, how transformation affects those functions, we will see what type of transformations can happen. Well, we already talked about that. We said that function can move up. You can move the graph up. You can move it down. You can move it left, move it right. You can shrink it closer to the y-axis. You can shrink it closer to the x-axis. You can do all of this, and the names for those transformation will be seen here in this in this the next slide. Now let's see the rules of transformation that we can expect on a graph. So if we consider f as one of the functions we saw earlier, f of x. So f of x is one of the basic functions, parent functions that we saw earlier, that can be absolute value, that can be the square root function, that can be the exponential function, logarithmic function, that can be any of the parent functions we saw. That's f. And then g would be a function after transformation, the resulting function after transformation. And here I summarize all that you can see happening to a function that gives you the resulting g of x transformed function. Well, we're looking at a lot of numbers. I mean, the letters are numbers. So A, that's this. B, here's your B. My H, K, and K. Now you need to make sure you identify all that those transformation that could happen, that can happen when it comes to transforming the function. Now, when you see a negative sign, it's itself a transformation. Now, when you're talking about transformation, you're not going to look at the negative and positive negative sign on the outside of the coefficient. If it's negative, you're not going to look at it as it is a number itself. You need to, that's why I circle my negative sign, because they will be seen as also transformation. We're going to talk about that. Now let's talk about that first negative sign circled on the outside. What does it mean? Well, whenever you see a negative sign multiplying, for example, you look at absolute value, you look at f of x equals absolute value of x. That is my parent function. Let me put it somewhere here. We put it here instead. Okay, you have f of x equals absolute value of x. That's the parent function. We know the shape is a V shape. But once I put a negative sign here, that negative sign tells me that this graph is flipped over the x-axis. It was looking up, now faces down. So if I go back to my absolute value graph, when it has a negative sign, it's like I'm looking at this over here instead of seeing the graph facing up. Just the negative sign makes this happen. That's a transformation. So that's why when you see that negative sign, you will not want to think that this is just a number, or if it was -2, the 2 would be treated differently. Say, for example, you have f of x, g of x instead. That's f of x. And if you have a g of x, the transformed function that is -2 absolute value of x, we transformed this function twice. Negative sign and then multiply by 2. Both of them will have a meaning in the transformation. So that will be your A, and that will be the negative sign. So let's explore all the parameters that describes that will be seen as transformations on a given function on a given basic or parent function. First, let's start with the negative sign, a negative sign sitting outside of the absolute value, of the square, of the radical, or any parent function. A negative sign sitting outside means that you have what we call a vertical reflection, or reflection in the x-axis. This negative sign sitting outside of the coefficient of one of the parent functions we showed you earlier will mean that this graph is flipped over the x-axis, flipped over the x-axis. Now, what the A would mean in terms of transformation? The A value means that you have a vertical, can be a stretch or a shrink. Now, when is it a stretch? Vertical stretch. When the A value is greater than 1, not greater than 0, greater than 1. Well, actually, the A is expected to be always be seen as positive. So that's why here I say A, B, C, D, A, B, C, A, B, H, K are always seen as positive. They are always seen as positive because a negative sign will have a different meaning. Okay, now A means that you have a vertical shrink or stretch. It's a stretch when A, that value outside, is a number greater in value than 1. If it's smaller than 1, then you're going to have something that is shrink. So it's always going to be a vertical. It's outside, number, vertical. Shrink or stretch. Stretch greater than 1, shrink smaller than 1. And then you're going to say this is a transformation will be named vertical stretch of a factor A. Vertical stretch of a factor A, or vertical shrink or compression, or compress with of a factor A, the A value, the value. For example, if I have f of x, g of x instead, if I have g of x equals, I don't know, -2 absolute value x, two transformations happened. I reflected the graph of absolute value x in the x-axis, make it face down, and then I compressed vertically this graph with a factor 2. And you would look at this graph, instead of, it will be farther away from the y-axis, meaning closer to the y-axis. It's like you bring it down. You bring it down closer to the x-axis. That's a vertical stretch. That's a vertical stretch. Well, actually, it will be closer to the y-axis. It's like you close it to the y-axis. So basically, a vertical stretch of the absolute value will be inside of this over here. Something like this will look like it's getting closer to the y-axis with the effect of a vertical stretch. Whereas if you have a vertical shrink, that can be, well, I'm calling 1/2, for example, then at this point, your function, your graph will be closer to the x-axis, like moving away from the y-axis. You would see something like it opens more, meaning moving toward the x-axis. Okay, so that would be that would be a vertical shrink or compression. And something like this something looks like this would be seen as the vertical stretch. And this is when A is less than 1. When A less than 1, this is when A would be less than 1. And then over here, you would have an A value that would be greater than 1. Okay. Now we talked about the vertical compression, vertical stretch. Now let's talk about that. And that was A. A is the vertical compression, vertical stretch. Compression or shrink is when A is less than 1. Stretch is when A is greater than 1. A vertical stretch gets the graph closer to the y-axis. A vertical compression or shrink gets the graph closer to the x-axis. The negative sign in front of A on the outside of the actual parent function affects it in a way where it flips it over to the y-axis. Now let's move on to the next. Let's look at a negative sign inside of the function. If it's an absolute value, inside of the absolute value, not on the outside. A negative sign inside of the radical or before squaring the x will mean that you have a reflection in the y-axis or a horizontal reflection. A horizontal reflection. That means if I have f of x equals negative x squared. Well, I know this is x squared at this because oops, no, not the square is outside. I know that would be the same result, and that's why if you flip the graph over, let's say for example we take this function here. I give this side pink and this side blue. A reflection in the y-axis would mean you flip the blue and the pink. But if it wasn't blue and pink, you wouldn't make the difference, right? And that's why even if you put the negative sign inside of the radical inside before you take the square, you would get the same thing. But looking at the negative sign inside versus looking at it outside means different thing. Because when you square it before you take the negative sign before you take the square, you don't change it. And that's why the reflection in the y-axis for a function that is an even function like x squared would not be something that you would be able to see on the graph. The only time way you can see it will be in the equation if it's given to you. Just wanted to make this point here. So horizontal reflection is when you have a negative sign on the inside, and also called a reflection over the y-axis. And how about B? What is the role of B in terms of transformation? B is a horizontal stretch or a horizontal shrink, but it reverses the roles. Remember, for a horizontal stretch, the A value should be greater than 1. But a horizontal stretch I mean, for the vertical stretch, A value should be greater than 1, but for horizontal stretch, B must be smaller than 1. But remember, when I say smaller than 1, I'm not talking about that negative sign. We already discussed the negative sign that could or could not be in front of the B. We'll talk about the B itself separated from the sign negative. Less than 1 means that you have a horizontal stretch. Greater than 1, you have a horizontal shrink, also compress. And then you have a horizontal stretch or shrink of a factor 1 over B. So you reverse it to give the factor. The factor is not just B. The factor is 1 over B. Versus the vertical one, the factor was the actual number you're looking at. For example, if I take f of x parent is, well, I'm just giving anything, right? X squared. And then g of x, the transformed function, I give you something like -1/2 x squared, like that. Well, you see this? You see that the -1/2 is B. Why? Because it multiplies the x prior to the square, because the square is my actual function. That's why it's quadratic. Now, because the coefficient -1/2 multiplies x before taking the square, before taking the square, so that means after taking the square would be -1/2 x squared. Those two are not thus, because this one would mean a vertical transformation, a vertical two transformations would happen. But let's talk about these two, because they're different. One multiplies x, one where -1/2 multiplies x and then you square. The other one is when the -1/2 multiplies the x squared. The 1/2 multiplies x squared, and then -1/2 in the first one, in this one, multiplies x. So it's different. Multiplying 1/2 x versus multiplying x squared is different. Now, because the x squared, the -1/2 in the first example here multiplies x, not x squared, this is a horizontal transformation. Can be stretch or shrink. But first, what's the negative? The negative, because it's inside, will be seen as a horizontal reflection, meaning reflection over the y-axis. That's one. And second, 1/2 would be a horizontal stretch or shrink. Now, how do we know if it's a stretch or a shrink? It's because it's less than 1/2. 1/2 is less than 1, so it's going to be a stretch. And then the factor will be 1/1/2 or just 2. 1/1/2. So that's the reciprocal of 1/2, which is just 2. Because the factor for horizontal stretch or shrink, it should be 1 over that value. So that's just the factor here is 2, because you reverse the 1/2 coefficient. When B is greater than 1, you take 1 over B to get the factor. And then in this case, let me change the color here so we can make the difference. In this case, green, what we see is that we talked about it is -1/2 multiplies x squared, which is the basic function. We multiply it on the outside, which means before taking the square. We have a vertical transformation with a vertical two vertical transformations. The minus sign on the outside means that reflection is made in the x-axis. And then the 1/2, because it's outside, it's a vertical, and smaller than 1, shrink or compression. So this, and then I'll factor exactly what it is, 1/2. The factor here is 1/2. Because it's A. A, you don't change A. You only change B to 1/B when you're giving the factor. Okay, and then now let's move on to the next type of transformation, the H. And as you're looking at this, you see H can have a plus sign or a minus sign in front of it. That's why we keep in mind that H itself is positive, always positive. And when it have a negative sign, we will know what to do. When it has a negative sign, a positive sign, we would know what to do. All right. So H represents a horizontal translation or shift. If it's a plus sign, the translation is the graph moves to the left, plus left for H, plus left for H, plus left for H, and then minus right for H. Whereas for K, it's a vertical. H is horizontal translation. K outside is a horizontal translation. And if it's a plus K, up. If it's a minus K, down. Now we have a summary of everything that we need to know about transformation. We have the basic functions that are f in this equation here. All the f can be any of the basic functions we saw in the previous slide. G of x is the transformed function. So when you look at G of x, you see where it comes from, what family it comes from, based on its last name, the shape. The equation, if it has a square, so then the parent is square. And you know the shape of the parent. Cube, you know the parent is cube. That's where it comes from. No matter what numbers on the outside, minus sign or H or K or A or B, then you will identify what is the role of each number that was thrown into this equation, this radical square root function, this cubic function, this cube root function, this absolute value function, this quadratic function. All of them will be subject to those type of transformations that we saw: 1, 2, 3, 4, 5, and 6 transformations. We can perform all of them in the same function, or some of them. You don't have to do all of them. So you will be able to identify, what did we throw into this function? Is it an A? Is it B? Is it H? Is it K? Is it A with a plus or A with a minus? A with a plus, B with a plus, with a or minus, plus or minus H, plus or minus K, and then you would identify which of these transformations they correspond to. If you understand all this, then let's see. We're going to use these transformations, those given transformation here, to rewrite this each of these functions, these parent functions. First, we have the absolute value function, right? And then they say reflection in the y-axis. Reflection in the y-axis, let's go back up here. That means you have, that's the negative sign of B, meaning that B is inside. This negative sign will go inside. with inside of the absolute value. And then you have a vertical stretch. 4 goes outside. You have a horizontal shrink. A horizontal shrink, that means 3 is greater than 1. Because if it was a stretch, you would have a number that is less than 1. Shifted 6 units to the right. So let me say here that's A greater than 1. It's a stretch. That's B greater than 1 because it's a shrink inside. That is 6 to the right. That's H. That's negative H. And shifted down 2 units, that's negative K. Okay. And that's a minus inside, a negative inside. So for f of x equals absolute value of x, that's g of x would be 4 absolute value of vertical stretch. So that's going to be 3 with a minus in front of it because there is a vertical, a horizontal reflection or reflection in the y-axis. And then we need to put parentheses because everything that will happen to the x, we will need to keep the 3 on the outside. The 3 will not just multiply the x, it multiplies x and any horizontal transformation that would happen. And then x minus 6, is it minus 6? Because it's h minus, so minus 6, close, and then minus k. K is 2. So g of x would be 4, absolute value of negative 3, x minus 6, x minus 6 minus 2. Minus 2 on the outside. And then for each of these other functions, we're just going to replace the absolute value by whatever the parent function indicates. So the b squared, that's going to be g of x equals 4 negative 3 x minus 6 squared minus 2 f of x, g of x equals 4 negative 3 x minus 6 cubed minus 2. G of x here is the cube, 4 times the cube root of negative 3 x minus 6 minus 2. That's square root. The only difference would be removing the cube part. So that is g of x equals 4 square root of negative 3 x minus 6 minus 2. This is g of x equals, that's the exponential function, 4 b exponent negative 3, x minus 6 minus 2. Because the x, you replace it by this part in the exponential function and then keep the 2 down, the negative 2 down. This one will be g of x equals 4 log base b of negative 3 x minus 6 minus 2. And then finally, the inverse, that's g of x equals, well, you could say 4 times 1 over, but it's just going to be automatically 4 over negative 3x minus 6 minus 2. So these are the same transformation that we use here. I just incorporate them for each of the basic parent functions that we saw earlier in the previous slide. In that next example, that'll be example number 2. In that next example, we're going to do the reverse of it. I'll give you the function with the transformation, and then you will identify what type of transformation each of these are. So basically, that's the result that we will have. We will have first identify the parents, and then we look at the chart that we have here, and then explain what transformation each of these are. If of these is, so the first thing we see, the minus sign on the outside means that there's a reflection in the x-axis, right? And well, let's identify the values. So that's the minus sign, which means a reflection in the x-axis. This number 0.45 is A, but it's less than 1. So that's why we say that is a vertical shrink. Now let's go inside. That is B. B is greater than it. B is less than 1. So we know that we have a stretch of a factor that should be 2. A stretch of a factor 2, because you need to take the reciprocal of 1/2. That is 2, because it's inside. The factor should be the reciprocal of the number that is in the equation, and it's inside. That's why it's a vertical stretch. It's B equals 1/2. That's less than 1. That's why it's a stretch. And then when you take the reciprocal, it gives you 2 for the factor. We have plus 7. Plus 7 meaning inside. Plus 7 inside, it means that you have a shift that moves to the left. The plus sign inside that added to x is a shift left. And then outside, you have a plus 1. So that this one is H, 7 is H, and 1 is K. With a plus, that means it's a shift up. And we do the same analysis here to get the description of this one. Now, let's go to this example that you have on your notes. You have the note for this one. First example, remember, you're looking at this, you tell that this is a absolute value graph. But the parent for the absolute value is what looks like this, right? And then this. Ah, okay. Okay. Now, let's see what happens here to get this graph. They moved it up. Remember, that's where the parent function would have sat at, but moved it 1, 2, 3 up. So we have k equals 3 with a plus. And then they moved it to the right 1, 2, 3. So that's h, right? Because that's h equals 3 with a plus. We moved it up 3 with a minus because it moves to the right, and we remember right is minus in the equation. Well, minus in the equation. So h equals 3 here because it went right. But when you're putting it in the equation, you know that because it went right, right means minus in the equation. So first, we identify it as an absolute value. We're going to say that the parent function is absolute value of x. And then the transformations, the two transformations we had was going left 3, right 3, and up 3. So right g of x will be absolute value of, inside we have x minus 3 because it went right, and always right we keep it to the with a minus sign inside, and then up 3 plus 3. We can look at this graph. We see the parent is x squared. We see that it went down. That's where the function should have been. The parent should have been sitting. That this point here should have been here for the parent. So they moved it down 1 to 3. So that is, there is a minus 1, 2. There is a minus 2. And then they moved it to the right 2 times as well. Oh, wait, not really 2. They moved it just 1 because that's where it stopped. So that will be x minus 1 squared. So this next function is the radical function, but they are asking us now, what transformation do you see here that takes this function to this one, that transform square root of x to this? Well, first I see a negative sign on the outside, which means that there is a reflection in the x-axis. So I'm looking at two transformations. There is that negative sign and then the minus 4, which I know that it's a shift to the right. So two transformations. That this one is a reflection in the x. And then this is a shift to the right, 4 units to the right. Okay, so I'm just going to look for those. Reflection in the x. And then there will be a shift right, a shift right. And then they want me to sketch the graph of this function. To sketch the graph of this function, I'm always needing some points, to be sure about what I do. And I'm going to show you how to do that using your graphing calculator. Okay, so now we have the graphing calculator right here. We're going to clear, making sure everything is cleared because we don't want anything that we don't want to show of you being graphed on the calculator. So I have my calculator well cleared. Well, I'm gonna turn it off and to start the process all the way from the end. Here. Oh, it's perfect here. Okay, so that's better. That's better. Hopefully you can see the calculator. You know, pull it down a little bit. Okay, so now um turn it on, the on button right here. Turn the calculator on. And then now I'm going to, first I want a table that will allow me to just count some numbers, because all I need is to have some values that I can be plotted. I can plot in my coordinate system and follow the pattern of the graph that I'm getting. And we're not going to forget that the what we are graphing is this new function here. And the parent function here is already given to us. So that's f of x equals the square root of x. And the transformed function g of x is this one here. Negative square root of x minus 4. So let me go ahead and type in my calculator the transformed function. But first, I want to get some given points that I will be placed in this T table so I can indicate the points that I will be using to plot my graph. So start with pushing the Y equal button. The Y equal, there's a button right on top on the left. The first button on the left, Y equal, we push it. And it gives us the option to type our function. So that means you can type all, if you have the same calculated TI 84 plus CE, it gives you color option. That's why I like it. And then it gives you many Y value that you can type in all these functions. If you type a function in each of the Y1 through Y9, you're going to be able to see the graph or the table in depends on what option you ask for. But let me go ahead and type my function. We start with a negative sign. My function start with a negative sign. So we don't want to use that minus sign. You use the negative sign at the bottom in parentheses whenever you start, like a negative sign. That's a negative sign, that's a minus sign. So negative. And then the square root, you can see how it's in the x square button, but it's in blue above the button. So that means I need to get the second option, and then the x square button will give me the square root. Now it gives me, you see how the square root pops in, and then it's the blanking. In the blanking here, it shows me well that they're ready for me to type my function. Function is x minus 4. So the x is that button xt theta n. That's where you can get an x variable, or if you push alpha x, alpha and then x in green will also give you x. So easy. I don't have to do two steps. There's one step, which is the xt theta n. Push this, gives me x minus 4. Then I tap my function. I can see the graph, but I do need a table first so I can get some specific values to get to my table. So to get table, that's the same graph button on the right top of the calculator. I can push it, it will give me the graph, but I need the table first. So table is in blue. The blue button is the second function. So second function and then table. Now I have a table. You can see how for all those values it gives, the function gives error, because for all those values you will get something negative inside of the radical. It will not give you anything. Starting at x equals positive 4, we get 0. So I'm going to put here x equals 4, y equals 0. I also see for x equals 5, y equals -1, 5, y equals -1. And I can look for more values that are integers, because I want to work with integers mostly. They are more precise. So 8 is -2. Let me see if I can find another one that is, well, no, can't find another one because the grid is not this much. So I can work with this, right? But I do want to see the graph just to have a better idea of what I'm going to have. So then now I can push the graph button. It gives me my graph. So I can see an idea of what it is. So let me go ahead and plot the points. X equals 4, y equals 0. X equals 5, y equals -1. And then for x equals 8, be -2, will be a little bit further here. Just putting this here to make sure I get something accurate. But I could just do it without these last point. And then I can connect with the pattern just like I see in the coordinate in the calculator. Oh, this is not good. Let me try another one. All right, so here, and then that, you already get the idea how it's going to look like. Something like that. Okay, so that's the graph. Basically, that's how you're gonna do it. I may not show you all the steps to keep going like that, but basically that's how you're going to type the function. You're going to find some values and look at the graph using your calculator, using the graph function of your calculator, and then plot the points and then sketch your graph. So you use your graphing calculator and the table function, the graph function, and get your graph plotted, sketched. Our next example is also from the parent function square root. And the transformed g of x is this one, -2 square root of x plus 1 plus 9 on the outside. So we can tell how this negative sign is a reflection about the x-axis. The 2 is a vertical stretch of factor 2. And then this is a horizontal shift, or just say horizontal. Horizontal shift 1 unit, 1 unit left. And then this 9 is K, a vertical shift of a factor 9, vertical shift of 9 units, or shift. Let me just say shift 9 units up. Okay, now what we're going to look for those elements, reflection in the x-axis. We have a reflection in the x-axis, which is the negative sign on the outside. We have a vertical stretch of a factor 2. Vertical stretch factor 2. We have a horizontal shift up, left, shift left. And then last, we have a shift up of 9 units. Okay, now that we get this, then we're free to move on to graphing the function, right? So to graph that function, we're gonna want to make up this table, X and Y. Remember how to find those values in the calculator using your graphing calculator. And those values are, you type the function, you press the on button, you clear your calculator, you push the Y equal button, and then you type your function, and then second function, second, the blue second, and then table, it will give you those values. I got -1. I always, it doesn't matter which value you take, but if you take whole numbers, it will give you more precise values, which is better when you're graphing a function. -1 0, -1 9 0 7 3 5. I also have 8 3. Now I'm going to plot these values. -1 9, x equals -1, y equals 9. 0 7, x equals 0, y equals 7. 3 5, x equals 3, y equals 5. And then 8 3, x equals 8, y equals 3. And then now we can just sketch by connecting the dots. That is g of x equals -2 square root of x plus 1 plus 9. And here, that is the f of x equals square root of x that was given to us. Next example. This one is the quadratic function. That's the quadratic function. This is the transformed g of x. We're going to identify the values. So that's a. We know what a is. Go look at the model. That's h with a negative sign. And that is k, which is the vertical shift or shift up 2, shift up 2, shift right 1, and then vertical stretch of a factor 2. So let me find those 3 transformation in the list and select them. We shifted up 2, up 2. Oh. And then we shifted right 1, shifted right 1, and then we stretch vertically by a factor 2. We stretched vertically by a factor 2. And then we're gonna need a table to sketch. In this one, we do not have the graph of the parent function. So I'm gonna want to do a table for the parent and then a table for the transformed function. Okay. Now the parent is, remember, the parent function is f of x equals x squared, right? Whereas the transformed function is g of x equals 2x minus 1 squared plus 2. So what we're doing here is we're going to try to find some values. For x equals 1, let me start with x equals 3, for example. -3. -3, we square it, we get 9. -2, we square it, we get 4. -1, we square to get 1. 0, we square to get 0. It'll take more, but you don't have to. And then we have 1, 1, 2, 4, 3, 9. So we have that. I'm going to plot these because they give me a better idea of what my graph is going to look like. Obviously, we've already known how what the quadratic function looks like, but it's always better, to be careful and then put the values down. So 0, 0, 1, 1, -1, 1, 2, 4, -2, 4, and then 3, 9, -3, 9. Then we can just go ahead and connect those dots. That's f of x equals x squared. Now we're going to work with the pair the we're gonna try to use the calculator to get the actual transformed function graph. So you remember how to type it in. We're not gonna go there for now, but you just can refer to the last the previous graph we sketched to get the steps, the calculator steps to get the table. In my table, I have for -1, we got 10. For 0, we have 4. For 1, we have 2. 2, we have 4. And then for 3, we have 10. I'm going to plot this. -1, 10, x equals -1, y equals 10. That's where this is. For x equals 0, we have y equals 4. For x equals 1, we have y equals 2. 1, 2. For x equals 2, y equals 4. For x equals 3, y equals 10. So then you can connect these dots. Does not have to be perfect. You just have to show the pattern of the function, and then that would be the graph of your transformed function. G of x equals 2x, 2 parentheses x minus 1 squared plus 2. We're gonna work on more examples here. Next one is still the quadratic function, but this time we're gonna look at the numbers here, here, and here. We have let me change the colors to make the difference. I'll call this one red, and I'm gonna call this one we call this one green. So this is outside multiplication and smaller than 1, making this a vertical shrink of a factor 1/3. Well, sometimes they don't put that number, but they should have. But it's a vertical. First keyword would be a vertical shrink. So a vertical shrink of a factor 1/3, but sometimes they put 3. It's okay too. So you don't, if you don't see 1/3, then your best option will be of a factor 3, vertical shrink or compression. Vertical compression. Next, this is H, the red, it's H, meaning that it's a shift left of 3 units. A shift left of 3 units. Shift left. A shift left of 3 units. And then you also have a shift the green, let me change this to red. And then the green is a shift up of 2 units. A shift up of 2 units. Okay. And then we're going to quickly work with the graph. The parent graph is already given to us, makes life easier. We type the function, the transformed function in the calculator. And then what we get is for the table was for 0, we get 5. For -6, we get 5. And for -3, we get 2. And we're gonna try to see if we can work with those values to plot the function. -3, 2. X equals -3, y equals 2. So that's here. And then for the -6, we have 5. -6, we have 5. And for 0, we also have 5. So I'm gonna just try to follow the pattern here. Doesn't have to be perfect. That is g of x equals 1/3 x plus 3 squared plus 2. Let's go to the next example here. This one is a radical square root function. So we used to square root function. The negative sign outside is a reflection. Let me put the colors, they help. That's a reflection. This is a vertical stretch of a factor 3. This is a shift left 3 units. Shift left 3 units. And this is a shift. This is a shift up 7 units. Let's go ahead and find those parameters in the description. We have a reflection in the x-axis. Reflection in the x. We have a vertical stretch of a factor 3. Vertical stretch. Factor 3 is green. We have a shift. We have a shift 3 units left. A shift 3 units left. And we have a shift up 7 units. Shift up 7 units. Shift up 7 units. Okay. Now we're done with this. We can go with the use our graphing calculator to find some values. But because we already know how the parent will be, I'm just gonna sketch it without a table. It's square root of x. So x equals 0, square root of x is 0. X equals 1, square root of x will be 1. x equals 4, square root of x will be 2. X equals 9, square root of x would be 3. So that would be enough point for me to sketch the parent function. So that's f of x equals square root of x. Remove the table in this side. And then now I'm going to type that function in the calculator, and the values I get will be, the values I get are for x equals -3, we get 7. For x equals -2, we have 4. X equals 1, 1. And x equals 6 is -2. Let's go ahead and plot these values. -3, 7. -3, 7. -2, 4. -2 is 4. Now +1 is +1. +1 is +1. And then +6 is -2. And then we can go ahead and just connect the dots and get the, follow the pattern. That is g of x equals -3 square root of x plus 3 plus 7. Okay. And that is it for the section number 4, where we worked on transform function. We review all the rules of transformation of the function. We reviewed the parent functions. We graphed functions. We used the graphing calculator. And all those skills are important for you to understand the process of graphing function, identifying the parent functions, and also the transformations from a parent function to an actual transformed function.